So if you are asked to find the sum of a series, and it looks something like this example, and it is not geometric, then you want to determine if you can find it, if it's a telescoping sum. So that means we need to find the nth partial sum. So we need to, so if you're looking at this S sub 2, that's the sum of the first two terms. Here's the sum of the first three terms. So in order to find an expression for the nth partial sum, we're going to need to separate this term by using partial fractions. So you remember how to do partial fraction decomposition. So to find the A and the B, so went through this process. I'll do an example in a minute. So we put it together. Do not separate the sum. Keep it together. Now we're going to look for an expression for S sub n. So this is plugging in n equal 1 into this expression. This is plugging in n equal 2 into this expression. N equal 3. So don't immediately cancel, but stop and finally plug in n equal n, period. So nth partial sum is adding up the first n terms. Now we identify how things cancel. So they do cancel. We have to identify, oh yes, in this between ... land, things are going to cancel. So the only two terms I'm left with are these two. This is the nth partial sum, so we make a sequence out of it, and to find the limit of a sequence, we take the limit as n goes to infinity, so here we get 1. So let's do one all on our own. So this would say converge or diverge. If convergent, find the sum. So as soon as it says this, you identify, is it geometric? It is not, because it is not to the nth power. Geometrics always have nth powers. So this would encourage me to do partial fraction decomposition and do this telescoping method. So A, let's fix that, A over n plus B over n plus 2. And remember how to do partial fraction decomposition. I'm going to multiply both sides by the denominator, n times n plus 2. So I get 4, and then I'll get A times n plus 2 plus B times n. So here's where I'm going to choose wise numbers and let n equal 0. And so if n equals 0, I get 2a, so 2 is equal to a. And then if I let n equal negative 2, I get 4 is equal to negative 2b, so negative 2 is equal to b. All right, so I put those two into, so this sum turns into this sum, plus negative 2 over n plus 2. Okay, so we want to make sure we put this subtraction, one of them will always be negative, put it in the middle. So make sure you're always putting the subtraction there, because you're going to want to make a nice S sub n expression. You want to see how things cancel. So S sub n, if I plug in n equal 1 into this term here, I get 2 minus 2/3. So that's plugging in n equal 1 plus. Now go plug in n equal 2, so I get 2 over 2 minus 2/4 plus n equal 3. So 2/3 minus 2 over 5 plus n equal 4. So sometimes it takes a few terms. 2 over 4 minus 2 over 6, ... Okay, so I need to go figure out, well, I know the nth term will look like 2 over n minus 2 over n plus 2. So I need to identify how these terms are canceling. So let's go look. So the 2 stays, 2/3, oh, there it is, way over there, 2/3. 2 over 2 stays, 2 over 4 cancels with way over here. So let's identify the pattern. Last one in this group, skip a group, first one in this group. So last one in this group, skip a group, first one in this group. So we'll be doing all the way, all these next terms will cancel. So let's write down what the n minus first term will be, not n equals 1, n minus 1 term. So the n minus 1 term, so plugging in n minus 1 into the nth term. So let's think about, and let's go one less, n minus 2. So I get 2 So dot 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 2 over n minus 2 minus 2 over n. Okay, so it's the last one in the group, skip a group, first one in this group, last one in a group, skip a group, first one in this group, last one in the group, skip a group, first one in this group. So we can see these ones are all canceling. So what I get for my S sub n is 2 over 2 plus 1. All the rest of the terms are canceling until we get to these two. So now, in order to find the sum, I take the limit as n goes to infinity of this S sub n term, and this will give us the sum. So this gives me 3. That's the sum, and it converges.